Welcome back everyone with the new topic, that is height and distance. So this is primarily a introduction of height and distance, as well as this topic is more or less an application part of trigonometry only, right? So what we are going to do in this topic is, as the name suggests, we are going to find out various heights as well as distances between the 2 points using trigonometric ratios, right? So while learning the trigonometric ratios, you must have realized that there is sine, there is cos, there is tan, and there is cot, sec, cosec. All of those trigonometric ratios can be used to measure height as well as the base, the distance, and as well as the hypotenuse of any given shape. Now what if that shape is in a building? For example, let us have a look at these two pictures. Now as you can see right over here, this is what? This is a very famous monument, and over here this observer, small observer AE, is situated, and what he is saying, he is looking at the top of this Eiffel Tower, right? And as you can see, this is what, here is the height, and this is what the distance from the base of Eiffel Tower to the observer. So using some trigonometric ratio, I can definitely find out the relation between the height and as well as the distance, that is AB or ED. Similarly over here, as you can see, this boy is watching this ball on the ground. Now can you see that there right here is a right angle triangle, right? This is a right angle triangle, and if there is a right angle triangle, similarly there is also a right angle triangle. So if there is a right angle triangle, we can definitely apply trigonometric ratios right over there. And now as you can see, right from this point to the ground, this will be the height, that is the perpendicular, this will be the base, and this will be my hypotenuse. Now using various trigonometric ratios, I can definitely find out the angles. Now here is one important thing: angle of elevation and angle of depression. What is angle of elevation? Suppose AE, there is at point A there is an observer, and he is watching the, this is what we call line of sight. Line of sight is a straight line view at which it is a path, a particular path at which your sight goes, and up to a certain, it sticks to a certain point. So for example, this man's sight is going up to this tower and it is sticking right over there, right? So this is the line of sight. Now this line of sight is making what angle with respect to the ground? So for example, this is ground, right? And the line of sight is right over here. So what is this angle known as? This angle will be what? Angle of elevation. Similarly, if you look at in this scenario, the boy is watching the ball and he is making a angle with respect to the parallel of the ground. So this is what? This is ground, and if you go right over here, this is a line parallel to the ground, right? So this angle right here will be the angle of depression, and this angle right over will be the angle of elevation. So any which case, for example, we have been given the angle of depression. For example, we have been given this angle as, let's say this angle is given as x degree. Now how would you find out this angle? Because in order to find out the height, you need to have this angle right over here, right? This is the angle that is required. So how would you be able to find out this angle? So this angle what will be? Nothing but x only. Why this angle is x? Because as you can see, these are parallel line, and if this is a transversal, then this is a pair of alternate angle, right? Here we already have angle of elevation, that is the required angle. So with the help of this angle, we can definitely find out the angles. So this was the important point regarding the height and distance. Let us learn one more way. Now let us discuss regarding various types of triangles. What can be the situation, what could be the situation, I should rather say. See, this is theta, this is height, and this is, let's say, base, right? Now if or rather let's call it perpendicular. Let's call it perpendicular, and this is what hypotenuse is. This is my base and this is perpendicular. Perpendicular, right? Now, this here hypotenuse is represented by a, this is represented by base and this is represented by P. Now, here the angle is theta. If I generally look upon what could be the various possible angles theta can occur over here. For example, this theta is 30 degree. If this theta is 30 degree, then all you have to do is just to find out, and let's say one of the perpendicular and base is given, then what you have to do is just to apply your tan theta, and tan theta will always be relating to perpendicular upon base, right? And you know the value of tan 30 and then you can relate perpendicular and base. So, what if tan theta is 1 upon 30, theta is 30, so tan 30 will be 1 upon root 3, that is this value will be perpendicular and base will always be in the ratio 1 upon root 3. This is one important conclusion you have. Now, if perpendicular and base are in the ratio of, so let me just summarize it. If theta is equals to 30 degree, so my perpendicular will be 1 and my base will be root 3. My perpendicular will be 1 and my base will be root 3. So, if these are the case, then what will be the value of my hypotenuse? So, my hypotenuse will be what? All you need to do is just to apply Pythagoras theorem right over here. So, 1 square plus root 3 square whole under root. So, this will give me 2. So, if the angle, if this theta is 30, then this will be the ratio of perpendicular base and height. I hope it is making complete hypotenuse. I hope it is making complete sense to you, right? Now, coming forward to what if this theta is equals to 60 degree? Now, if theta is equals to 60 degree, then I can say that tan 60 will be equals to perpendicular upon base, and tan 60 is equals to what? Root 3 upon 1. So, this will be perpendicular upon base, and from here I can conclude that if theta is equals to 60 degree, then my perpendicular would be root 3, this would be 1 and this hypotenuse will be root 2 only, right. So, this table will help you a lot in order to solve questions, right. We will be actually solving few more questions based on how we can utilize this table very easily. So, without wasting much time on learning the concepts, let's practice the concept using some practice questions. So, see you there. Thank you so much.